Let's continue from where we left off yesterday. Okay, we all have our attention on board. So yesterday we were looking at tricycles, and we ended off at part 2, okay, that says, hence explain why this equation has two distinct real roots. And how we went about solving this question or explaining this question is that we took reference, okay, this is not answer, we took reference from our answers in part 1, okay, whereby we solve the equation, okay, and then we identify that there are two solutions, and then after that we explain that because there are two solutions, therefore there are two real roots. That is what we did yesterday itself. Then after that, before we ended, okay, and let's actually ask a question, can we use discriminant? So if you recall back when we were doing E-maths, I did introduce this idea to you, okay, and what exactly is the discriminant? It is based on this formula that we learned. Okay, we know that we can solve a quadratic equation based on our formula, and this formula, okay, there is a part that will help us determine whether, okay, how many solutions there are, and the critical one is this b squared minus 4ac, whereby we call it the discriminant. Okay, what does it actually discriminate? It discriminates, okay, how many solutions could there be in a quadratic equation. Okay.
Oh yeah.
How many solutions could there be for the quadratic equation?
I do this part.
Okay, it must only be quadratic equation because this formula doesn't apply for any other kind of equation. So in discriminant itself, there are several cases that we can consider. The first one is if the discriminant is positive. That means we are going to take square root of a positive number. Okay, so we will get two real roots because we will have minus b plus the square root of positive number, or the other case will be minus b minus always square root of the number. Of course, we must divide by 2a as well. Okay, so in this case itself, we observe that there will be two distinct or real and distinct. Okay. You will find the word real often coming up in your textbook, okay, E-maths, B-maths, right? That is just to emphasize that we're looking at real numbers, okay, trying to draw the distinction, okay, between real numbers and complex numbers, which you will learn for A-levels or when you pursue engineering, okay, and poly. Okay. Then we also learned yesterday that when it comes to roots, it is synonymous in the word to the word solution, and then also synonymous into the word x-intercept itself. Okay, so they imply the same thing. Okay, so having to say that there are two distinct real roots, it also means that there are two x-intercept. So in terms of the graph drawing, how it will look like?
Normal.
Okay. I'm just drawing with reference to the x-axis only. The y-axis doesn't really matter in this case. If it's a happy face graph, we will see that there are two intersections, okay, between the graph and the x-axis. Otherwise, it could look like that. Okay, and this is the reason why we need to learn how to draw sketches. Okay, it helps us understand the question.
Equals 0.
Okay? Yeah, where we look at equals to 0.
One solution.
So when it is equals to 0, that means you're taking square root of 0, and that is 0. So regardless of whether we're adding 0 or minus 0, there is only one solution in the end. So this will tell us that, okay, sometimes they will say that it is two real and equal or repeated roots, okay, or one, or else we can say as 1x intercept. Okay, I know that we will see as 1x intercept and you think that it is only one root, okay, but strictly speaking, it is actually a repeated root. Yeah, both the same.
That's why they do that equal.
Okay. Yeah.
I don't understand why are there two real and this.
As in, you don't understand this statement or you don't understand why two.
I don't understand.
Why two? Okay, I give you an example. Okay, so let's say, I just erase this. Y equals to 2x squared minus 4x plus 1. Okay, if we want to solve it, we can only solve when x equals to 0. Right? Okay, and how do we solve it? Using the formula, my b is negative 4 plus minus, my b squared minus 4ac will be minus 4 squared minus 4 1 over 2a. Right? Okay, so in this case, minus minus give us positive, plus minus, inside the square root itself, I will get 16 minus away 8, that is 8. So upon simplifying, I'll get this now. Okay, so what is inside the square root? Inside the square root is a number that is positive. When it is positive, what are we looking at? We are actually looking at two cases, 4 plus square root 8 over 4, or 4 minus square root 8 over 4. So there are two separate cases and they are going to give you a real number. That's why it says that there are two real and distinct roots. Okay? If the square root inside is a 0, regardless of whether you plus 0 or minus 0, same answer. Oh, okay? So that's why there is a contrast. Any questions?
No.
Okay, then considering positive and equals to 0 already, of course the next one that we need to look at is less
No
than 0.
0, no solution.
Yes, there are no solutions. Okay, so we get these three cases. Yes, teacher.
Wait, why you say got equal, like, what the
What does this two real and equal repeated roots mean, is it? Okay, now when you solve a quadratic equation, right? Okay, usually we are getting two solutions. Correct? Okay, so there is the expectation of the maximum number of roots that a quadratic equation can have. When it is the same, okay, mathematically we want to still cover the base that there are actually two roots, just that both the solutions are equal. That's why we call it two equal or repeated roots. They are the same solution. Now we don't have, because in the end we are just doing plus. Okay, I just change an example. Okay, let's say this one becomes 0, we're looking at plus 0, otherwise minus 0. They are a result of two cases and they happen to be the same. That's why we call it two real and equal or repeated, because they are the same, okay, roots. Yeah, so that's why we call it that. Okay, yeah.
Why is that when like it's a negative number inside the square root? Like why does it have no solution?
You can square root a negative number, right? try it. You cannot square root negative 1, right? Square root negative 2. Okay? Later on, when you go on to JC, you will learn that square root negative 1 is this number called I lah. Okay? That is a complex number. It's an imaginary number.
I knew it.
Okay? Yeah, which I think some of your calculators do generate that. Okay? Yeah. So some of your calculator, I know, I think the latest Casio one, if I'm not wrong. Yeah, when you solve it, okay, and if there are actually no real roots, right, they don't give you the error, they tell you, they show this I itself. Okay? So we must have the awareness lah, okay, that when you see I, it actually means that there are no real roots because this is a complex. Okay? Okay? For which, if you want to ask me more about complex numbers, I need to go and revise. It's been a while since I touched complex numbers. Okay? Alright? Any questions? Okay, so why is it that we want to learn all this? Okay, so in AMATS itself, actually we're not very interested in solving, okay, a quadratic equation to find out what exactly is the root. Okay, that kind of interest is limited to just AMATS. Okay? In AMATS, we just want to know how many roots are there, whether is there one root or two. Okay, so with that kind of interest, actually looking at the discriminant itself is sufficient already. There is no need for us to go and solve. Okay, because this can be a tedious process. Right, we can just answer the question directly by looking at the discriminant to know how many roots are there. Right, so let's take a look at try 7. In this case, because this is just a textbook question, it's specified for you to use the discriminant. Discriminant to determine how many x-intercepts are there. So don't need to go and solve it. Okay, all we have to do is that looking at this quadratic function, okay, we find out what is the discriminant. Like that. Okay, then we calculate out what is the value. So you must calculate out to provide as the evidence what is from your calculation. And that is equals to 28.
So positive.
Okay, which is more than 0. Therefore, we can tell that there are 2 real roots or 2 x-intercepts. Then for part B, okay, in this case, what do we need to do? Expand, okay, so must expand it. How to expand? A square. Okay, Mitchell, can you try? How to expand this one? Yeah, there's a reason why I call you. Because your homework. How do I explain this one? Using the identity. Then I know you can recite it. How to apply?
1 square bracket 1 bracket x minus x square.
Yes. Okay. Right. So that's the expansion. Okay. Then after that, get this. Okay. Then after that, we have our 1 minus away x plus x squared plus 2, which simplifies x squared minus x plus 3. Okay? Then we can calculate for the discriminant. Oh, thank you. Sorry, I got distracted. Thank you.
No solution.
Okay, no solution, huh? So 4 minus away 12, that will give us negative 8, which is less than 0. Okay, but let's answer the question directly. They're asking for number of x-intercept, not asking whether there are solutions or not. Yes. How about y-intercept? Do you think the question has y-intercept? It's an easy question to answer, right?
It definitely is.
Do you think it's ever possible for a quadratic equation to not have y-intercepts?
No.
Let's think about it. Yeah. Okay, we think of 3 cases, right? 2 y-intercepts, 1 y-intercept, and 0 y-intercept. Is it ever possible to have 2 y-intercepts? No, right? Okay, we know our graph shape, we know y-axis is like that. There can only at most be 1, right? That's not a quadratic function, right? Not a quadratic function. Okay, so this one, not possible. Okay, 1 y-intercept is the expectation. Okay, and then 0 y-intercept, is it possible? Never has any y-intercept? Have? Really? Okay, draw one for me. Okay, okay, Joker gonna draw one for me. Let's look at drawing.
Two lines.
Okay, he draw like that. I knew it and you draw like that. Let's look at this one. Draw it like this. Make sense or not? Benedict draw for him.
Let's go up.
You cannot purposely draw it such that it is going infinitely like that. That one not quadratic anymore. Okay? So, confirm it goes outwards one. Alright? Okay, so there will always be a y-intercept. Yes, you know. Why we draw a C? That's not a quadratic function anymore. That was what Alex asked also. Yeah, so this curve itself is a parabolic curve, which we don't cover in math syllabus anymore. But this is not a quadratic function anymore. It's not a quadratic function. Okay? It doesn't fulfill your y equals x squared or ex squared plus b plus c. We are partially going to learn it in your integration chapter next year. Yeah. Because we need to learn area under the graph. But yeah, don't need to worry too much about that. Okay. Yeah, so not possible. Okay. To have no y-intercept, it will always have 1 y-intercept. Okay. Yeah. Okay. So it cannot be. So this also helps us to remind ourselves, okay, when we are doing our graph sketching, which is the homework that I'm trying to mark now. Okay, I do notice that some of you, when you're drawing your curve, right, okay, you really just end up like that only, okay, and the x-intercept. I will encourage you to go further, okay, and then for some of you, the way you go further in drawing your curve, you draw it very straight like that, okay, and that is the reason why you may start misleading yourself now. Okay, so how a quadratic curve should look like, it should open up because it goes on infinitely, right? So that hopefully also answers the question that we had earlier on, asking why we have to learn how to do quadratic graph sketching. Okay. Alright, so that's how we apply our discriminant. Okay, let's look at another question looking at try 8. Yeah. are there. Sometimes in your question, you may be asked, okay, or given the condition that your quadratic function meets the x-axis at one point only. Okay, at one point only. So with this given information, okay, what is it that we can say about this quadratic function regarding its discriminant? Your discriminant must be equal to 0. Okay? Okay, so that will then help us to make use of this and also discriminant equals to 0 to determine the unknown p itself. Okay? So it's like the reverse of what we were doing earlier on. Right? So y equals to 3x squared plus 12 minus px. Maybe for some of you, you need it to be rearranged in order first, like that. Okay? Then we can find out the discriminant. That will be your negative p squared minus 4ac. Okay? What is negative p bracket squared? P squared, not negative p squared. Okay, so 4 times 3, 12, 12 times 4, 144. Okay? So p squared minus 144. Since the question has provided this information, we can then say p squared minus 144 is equals to 0. Then we can solve for the value of p. Okay, and p must be 12, is it? Is that the only answer? No, Okay. Remember when we take square root, okay, there must be 2 answers. So remember plus minus square root 144. Okay, so 12 or negative 12. The question didn't say what kind of value should p actually be, so both are valid answers. Okay. We want to also consider other possible cases, like what if it meets the x-axis at 2 points or no points at all, because we understand there are 3 cases regarding its discriminant. Okay, so instead of extending that question, just looking at this exercise 1.2 question 3, also talking about a quadratic equation or quadratic function. Okay, then asking us to find the value of k, or maybe a range such that there are no x-intercept, one x-intercept or 2 x-intercept. Okay, so we will investigate that by looking at the discriminant. So the discriminant itself, based on this function here, would be negative 2 squared minus 4ac. Right? And that simplifies to 4 plus 12a. Okay, so maybe we can just use the discriminant for all, so let's just do part I here, since it applies all the parts. Okay, so to say no x-intercept, what does it mean for the discriminant? Ravi? What does it mean for the discriminant when we say no x-intercept? Ask. smaller than 0 because in the square root sign, right, if it's negative, then no answer already. Okay, so we will say that 4 plus 12k is less than 0. So 12k is less than negative 4. K is less than negative 4 over 12. Okay, so in this case, we are expecting a range of values because we are taking an inequality over here. It's not possible for us to determine a certain value. Okay, many values satisfy that condition. Questions? Okay. If not, can you do part 2 and part 3 on your own? Okay, to determine what is the range of values or the value itself. Okay. As an extension, if you want to challenge yourself, okay, adding this part 4 also. I give you about 6 minutes. Yeah, Okay, I think all of you are done. Let's check our answers. Not done. What everything negative one-third? You think that? You think you look at what we're doing. Four plus 12k. Okay, are we all able to get this answer? Okay, Jovan is asking why is it everything is about negative one-third? What do you all think? Because actually for all 3 cases, the way you manipulate, you always shift the same thing, right? Shift the 4 over So obviously the answer will all be surrounding negative 1/3. Okay. So actually if you notice that, then you don't need to go through that series of steps. But in the exam, they will only ask you for one of the options. They will ask you for all. Not possible ones. Waste of class. Okay, we got more things to test. Okay. Now, why is it that I extended the question in part 4? Because I want us to think about at least one x-intercept. What does that mean? At least one means there can be one x-intercept or two x-intercept. Okay, so what should be the sign that we take over here? Okay, it should be greater than or equals to. Okay, because when it is more than 0, it means that there are two x-intercepts. Okay, to have one x-intercept, it is equals to 0. So this is a consideration of both part 2 and part 3. Hence, our sign needs to be more than or equals to 0. Okay, so by doing our manipulation, you would get k more than or equals to negative 1/3. Right, because the manipulation remains the same as well. Okay, questions? Alright, let's look at try 9. Okay, let's look at try 9. Oops. It says, explain why the graph of the quadratic function where p more than 1, okay, so there is this critical information here, intersects the x-axis at 2 points. Okay, we're trying to explain why. Now this is the part where we need to be very clear about what the objective of the question is and what the question is given us as information. Okay, the question is asking us to meet this objective. Okay, so my question down here is, can I say at the start, right at the start, that b squared minus 4ac is more than 0? Can I say right at the start that b squared minus 4ac more than 0? Then after that I continue to find the answer. Can I say that? How many of you say yes, I can do that? How many of you say no? Okay, I guess the rest means not sure. Okay, so the objective of the question is to explain why this is going to happen. So you cannot use b squared minus 4ac at the beginning, because that is what you're supposed to show, that is what you're supposed to determine at the end of the question. Okay, so you cannot right at the start say that b squared minus 4ac is more than 0. Because when you do that, what you're going to end up getting is the value of p. But the question is not asking you to find the value of p, like what we did earlier on. Okay, the question is asking you to prove something. So to prove something, that should come at the end. Okay, so we need to provide the evidences in order to justify that statement. So your b squared minus 4ac more than 0 should be a statement that comes right at the end of your answer. Okay, so if you read the question carefully, that is what the logic of it actually tries to convey. Okay, so with our y equals to x squared minus 2x plus 2 minus p, okay, I hope you can identify the correct a, b and c, okay, for us to use our formula, or rather our discriminant. A is equals to what? 1, b is equals to negative 2, and what is c equals to? Is it 2? It's just minus p? 2 minus p, okay? So it is 2 minus p, right? We must recognize the correct constant. Okay, so b square minus 4ac would then be negative 2 square minus 4 times 1 times c. Okay, and that simplifies to minus away 8 plus 4p. Okay, which simplifies to negative 4 plus 4p.
So 4p.
Okay. But can I just say that this is more than 0? Do we know that it is more than 0? No, right? We have no idea. So I mentioned again, this is the objective. Your p more than 1 is actually the given information. You can use the given information to help you in your proving. Okay, and how are we going to use this given information of p more than 1? Okay, so remember how we actually manipulate our inequality. Okay, we want to show that this is going to be more than 0. So we know that p is more than 1. Sorry, let me change the marker. We know that p is more than 1. This is our expression for the discriminant. So we multiply by 4 on both sides first. Okay? Then after that, I minus away 4. And what does that result in? It results in 4p minus 4 becoming more than 0. Okay? So this process is our evidence to show that for this particular graph, there will be 2 s-intercepts. So we say that since the discriminant is more than 0, condition 6, discriminant more than 0, as per shown over here, the graph intersects the x-axis at 2 points. So our concluding statement itself, we can always follow the same phrasing as our given question. Okay, but you need to have the concluding statement. Yeah, we can use it. Okay. So we need to be able to distinguish between the objective of the question, okay, and what is the given information. It was very different from just now. It was a given information, given task. Okay, for you to use the fact that there are no s-intercept, 1 s-intercept or 2 s-intercept to actually find the value. Okay, earlier on the question was to find the value. In this case, it was to explain why there are 2 s-intercepts. Okay. Any questions?
No.
Yes, Alex.
Presented
How do we present it as per how I write it? Yeah, everything. Yeah. Right from here all the way to here. Yeah. Okay. Let's look at try 10. Okay, let's look at this question. We want to show that the graph lies completely below the x-axis. So what is the objective of the question? To show what? Okay, maybe you give me the worded first rather than telling me what happens to the description. Based on the words of the question, Okay, what is it that you want to show at the end? That it lies completely below the x-axis, right? Okay, so this is our objective, okay? Then we need to think backwards, alright, to realize what does that mean for our discriminant. Okay? Okay, so we must know the objective, then we think backwards to understand about the discriminant. Okay? Now, there is something that I have not yet mentioned, okay, about this idea of being below the x-axis itself. Okay? First of all, do we agree that when it is completely below the x-axis, that means there are no x-intercept? No. Completely below the x-axis.
That means it doesn't contact.
Doesn't touch the x-axis at all. Yeah, so the x-axis is here. Being completely below, it means that there is no intersection with the x-axis.
It must be a front.
Right? But then, we know that if I have a graph like that, a shape like that, is this considered completely below the x-axis? Based on drawers, I would guess you would say yes. Or because it insists that based on how it's drawn, yes. Okay? But it is no. Okay? If you have a shape like that, okay, it doesn't count as being completely below because we know that our graph goes forever. So there will be segments of the graph that is not completely below the x-axis. Right? Okay? So it cannot be this shape that will say that it is completely below the x-axis. Okay? So there is a certain shape that will allow for this to happen. And that is a round face. Okay? Your set face graph. Okay? Because only in such a graph, no matter how you extend the graph, okay, it will always be completely below the x-axis and there is no x-intercept at all. So there are actually two conditions for it to be completely below the x-axis. One of which is that there cannot be any x-intercept. So this tells us no x-intercept. Okay? But then, we also see from here that your shape must also be a set face. Okay? Which is only possible when your coefficient, which is your A, is less than 0. Okay? So there are these two conditions that need to be met in order to achieve this. Okay? Your question? Why can't that be? Because the understanding of line completely below, like completely below means never touch. That's the wording. That's the meaning of being completely below. Okay, completely below means that there should not be any x-intercept. Okay, if you say that there's only one x-intercept, right? At this particular point here, is it completely below the x-axis? No, right? It is on the x-axis. Okay, so that's why you cannot say one x-intercept means that it's completely below. Right? So these are the evidences that we need to show in order to justify this statement over here, the objective. Right? Are we clear about the understanding of the question? So we haven't proceeded. Okay, so now we do our working. Okay, so with our quadratic function here, okay, we identify our A, B, and C. I hope you can see that these are our A, B, and C. Okay. Then our B square minus 4AC, our discriminant, will be 2K bracket square minus 4A. C is with the negative sign. So it should look like that. Okay, upon simplification, we get the 4K squared. To expand this or to multiply this, we will get a plus 4 first, followed by negative k squared plus 1. You can do it faster if you are able to. I'm just trying to demonstrate it for those that still cannot catch up yet, which is fine. Okay, nothing wrong with it. and we're only left with negative 4. Okay? So there's no inequality that we need to manipulate, and it is less than 0, right? But in our concluding statement, so if I were to continue my working here, I cannot just say that the discriminant is less than 0, and hence the graph lies completely below. Okay? I must also say that the coefficient of x squared is negative. Okay, which is negative 1. If you want to be clear, write it this way. Okay. Then the graph lies completely below the x-axis. Okay, so there are two conditions, and we must specify both. Just by saying discriminant less than 0 doesn't justify that the graph lies completely below. Because we know that when the coefficient is positive, when it is a U-shaped curve, okay, like that, discriminant less than 0 and U-shaped, it looks like that, but this is not completely below the x-axis. Okay, right? The other one is not possible. So the only possibility is this, by the shape methods and the discriminant methods. Okay, yes, Jun.
For the x squared equals to negative 1 is less than 0, right? We put negative 4 in the middle.
Negative 4.
No, the answer is negative 4 is less than 0.
That one is a discriminant. Negative 4 is a discriminant value. This one is a coefficient of x squared. So two different evidences on two parts that we must show. This one, actually, we should write it down yesterday, consistent. Okay, questions? Right? Okay, if you understand the concept that I've delivered here, I want you to give part B a try, but the function and the question is slightly different. It wants you to show that it is always positive. So, what does it mean to be always positive? Okay, when you do your own proof over here, I'll give you 5 minutes to do. Yeah. Okay, we look at this question. Okay, some of you are being distracted by the word positive. Okay. So let's understand this question. Okay. We are given this expression. Okay, totality wise. Okay, if I compute the whole thing, if I know what is x, if I know what is k, okay, what does it result in? It results in y. Right? Okay, gives us a y value. Okay, so what we're trying to show is that we want to show that our y value is always positive. That means all the points on your graph itself, okay, is above your x-axis. We agree with that? Your x-axis is here, your y-axis is here. Okay, we want every y coordinate to be positive. 0 is not counted as positive. Okay, so that's why our graph itself, right, cannot intersect with the x-axis. To say that it is always positive, it means that your discriminant must be less than 0 due to no x-intercept. Okay, and it must be this shape actually. It cannot be the other shape. Why? Because think about it again. If I draw a set face that is above the x-axis, okay, does it really always? Is it really always positive? It isn't one, because we know that it goes down. Finally you learn. Okay. So because because your graph extends what? So there are segments of it that is not positive at all. Your y value is actually negative. So this shape is not valid. So that's why in this case there are two conditions. Your discriminant being negative and your a value, which is your coefficient of x squared, must be positive to get a U shape. Okay, which explains why the discriminant ends up becoming negative. Okay, everyone understand? Yeah. Larger than zero. No, we agreed that saying always positive means that it will never touch the x-axis. To say that there are no x-intercept, that means your discriminant must be less than zero. Okay? So this idea of always positive is referring to the y coordinates, not to the discriminant. The discriminant discusses your x-intercept. Okay? I know a lot of thought to be done over here. Yes. Why can't it be equals to zero? So like what Jovan asked just now, what happens when it is equals to zero? There is then one x-intercept. And having one x-intercept, it means that your corresponding y value is actually zero. Zero is not positive, neither is it negative. But the question says always positive. Okay, so that's why this possibility is not possible. Or in this case, it's not possible. Okay? Any questions? Okay, so let me show the working. I noticed that some of you still a little bit confused in terms of recognizing your A, B, and C. The question did not state why, but you can introduce it. Or you want to use fx also can. Okay. Now, this is the part where maybe if you use fx, it might be better. Okay, to help you remember that your function here is in terms of x. X is the variable. Okay. What does that mean? That means that we're looking at the x-axis, not the k-axis. We cannot have both a k and x-axis. Okay, our graph is two-dimensional. I can only have x-axis or y-axis. Okay, so x is the variable in this case, and that will help you identify that this is going to be your A, and then your B is going to be K, in fact positive K, and then your C is the constant. Okay, it has no association with the x. Okay, so K is actually a constant. It is a number for which the question did not ask you to go and find. Okay, so we must be able to get used to recognizing constants, recognizing numbers that don't have a value to it. Okay? So upon recognizing this, then we can find our discriminant. So don't put it down here minus. So there is still a set of brackets which simplifies to this. So end up you get minus 1, which is the expected, because the question wants you to show that it is always positive. If you don't get less than 0, that means something is not right. Okay? So to conclude, we will say that since discriminant less than 0 and coefficient of x squared equals to 1/4, which is more than 0, then the function or the graph is always positive. Okay, so write your concluding statement. Yeah, Megan. Yeah. Okay, yes, teacher.
So why you use fx?
Why do I use fx? Just like I said, using fx helps us to remember that in this entire expression, x is the variable. So we're looking for coefficients of x squared, coefficient of x, and the constant term. okay, is to help us remember. You want to use y also can, because the question did not introduce fx or y. Yeah. Okay, just that I want to use fx now to help us all remember that x is the variable in question, that our axis is actually the x-axis, not the k-axis. Okay, because some of us cannot quite distinguish between a constant and a variable. Okay. Questions? Okay, I think I don't want to give you any more new question already. I can see your brains are fried. See the smoke out of your heads. Okay, I just want to sum up, alright, very neatly, okay, what we have learned today. Okay, we learned about the discriminant being more than 0. Okay, that tells us that there are two x-intercepts or two real and distinct roots. okay, that we need to have in order to not have any intersect with the x-axis. Then the last one is always negative and completely below the x-axis. That means that we must have this shape. Okay, there is only possibility that will result in this. Okay, so these are the 6 key points that we have gathered today based on the questions that we did. Okay, so tomorrow we'll do more. Okay, and once we're done with that, then